In 1905, the man who would change the universe was not a professor. He was not respected. He was not even invited into scientific circles. He worked behind a small wooden desk in a Swiss patent office, reviewing inventions that would never see the light of day. No laboratory, no assistants, no reputation. And yet, inside this forgotten man lived an idea so dangerous that it would tear reality apart. But before Albert Einstein became a legend, he was something else entirely, a disappointment. Einstein did not fail once. He failed quietly, repeatedly, and publicly. As a child, he spoke so late that his parents feared something was wrong with him. At school, teachers described him as slow, distracted, incapable of following rules. Every morning, Einstein walked the same streets, same coat, same route, same silent frustration. At the patent office, he evaluated other people's ideas, mechanical devices, electrical concepts, minor innovations. Stamp, reject, approve. All day long, he judged futures that were not his own. And every night, he returned to a small apartment, sat alone in silence, and questioned the one thing that truly terrified him. What if they were right about me? But there was one thought he could not escape, a thought that returned again and again, no matter how tired or discouraged he became. Einstein began to imagine something impossible, not an experiment, not a machine, a question. What would happen if I could ride on a beam of light, not observe it, not measure it, ride it? If light never slows down, what happens to time? What happens to space? What happens to you? These questions had no place in the scientific world of his time. They had no equations, no approval, only consequences. If Einstein was wrong, he would confirm what everyone already believed. If he was right, then the universe itself was broken. At night, the walls of his apartment felt closer, the silence heavier. Einstein knew the risk. He had no safety net, no academic position to protect him, no reputation to soften failure. One wrong idea would not just be ignored, it would erase him completely. And yet, the thought would not let him sleep. Because some questions are more powerful than fear. Within months, Einstein would write papers that required no laboratory, no instruments, no permission, only imagination. 4 papers, each one challenging reality itself. But before the world could be changed, Einstein had to take one final risk, trusting his thoughts more than the world that rejected him. One of them looked directly into his eyes and said, "You will never amount to anything." Years later, when Einstein applied for academic positions, his letters went unanswered. His ideas were dismissed. His name meant nothing. History remembers genius. But in 1900, Albert Einstein was invisible. Einstein did not begin with equations. He began with something far more dangerous. A thought no one could test. A question no one could prove. In a world that trusted experiments, Einstein trusted his mind, and that choice would isolate him completely. At the patent office, surrounded by other people's inventions, Einstein realized something terrifying. Every machine depended on assumptions about time and space, and no one had ever questioned those assumptions. Not seriously. Not like this. While physicists argued over decimals, Einstein asked a question so simple, it felt almost childish. What does the universe look like if time itself is not absolute? Einstein knew the rules. Time was supposed to be the same for everyone. Space was fixed. Motion was relative, but only up to a point. These ideas were sacred. Challenging them was not curiosity. It was intellectual suicide. Late at night, Einstein filled pages with crossed-out thoughts, diagrams that led nowhere, sentences he didn't dare finish. Because once you question time, you cannot go back. The light returned. Always the light. Einstein imagined 2 observers, one standing still, one moving almost as fast as light itself. if both measured the same event? Who was right? The answer should have been simple. It wasn't. Time stretched. Moments refused to agree. Simultaneity collapsed. Einstein realized the truth slowly, and then all at once. Time does not behave the same for everyone. This was not a discovery. It was a fracture. If time could slow down, then clocks could disagree. If clocks could disagree, then cause and effect were no longer absolute. The universe was no longer stable. Einstein felt excitement and fear because no one would forgive him for this. Einstein now understood the danger of his idea. It wasn't wrong. It was worse. It was correct. And once written down, it could never be taken back. The paper was almost finished, but the world was not ready. Einstein thought the hardest part was over. The idea was clear. The logic was elegant. Time was no longer absolute, but clarity can be deceptive. As the final lines of his paper took shape, a quiet doubt began to grow. Not loud enough to stop him, not strong enough to erase the idea, just enough to be dangerous. Einstein had broken time, but he had not yet faced gravity. At first, the omission felt harmless. After all, gravity belonged to another world, one of force and mass, not light and motion. But the more he thought about it, the more the absence began to echo. If time could slow down, if motion could reshape reality, then gravity could not remain untouched. And that was where everything began to unravel. Einstein tried to force gravity into his new framework. He pushed equations until they bent. He rearranged assumptions until they almost made sense. Almost. Late at night, alone with his notes, Einstein realized something terrifying. His theory worked beautifully, but only in a universe without weight, without falling objects, without planets, without stars. The real universe was messier. For the first time since the idea had emerged, Einstein felt the sharp edge of failure again. Not rejection, not ignorance, error. If he published too soon, the flaw would be exposed. His name would not be remembered for changing reality, but for misunderstanding it. And unlike before, this time the mistake was his alone. Days passed, then weeks. Einstein returned to the patent office, stamping papers with steady hands while his mind collapsed inward. Every solution led to contradiction. Every correction created new problems. The theory resisted completion. It was as if the universe itself refused to cooperate. In moments of exhaustion, Einstein considered abandoning the idea entirely. Let it remain unfinished. Let it fade quietly. But the thought was unbearable, because even broken, the idea was still true. Something fundamental had shifted, and Einstein could feel it. Time was no longer safe. Space was no longer solid. The mistake did not erase the discovery. It delayed it, and delay can be cruel. Einstein understood now that one paper would not be enough. One insight could not carry the weight of the universe. This would take years, possibly decades, and he would have to walk that path alone. When Einstein finally put down his pen, he did not feel triumph. He felt something colder, patience, because the idea had survived the error, and that meant it would return. Stronger, heavier, impossible to ignore. If time could bend, gravity would follow. But not yet. The world would have to wait. And so would Einstein. If a single mistake can delay truth for years, how many truths are we still waiting to understand? After the idea fractured, the world went quiet. No applause followed. No recognition arrived. No letters of excitement or outrage. Only silence. Einstein's papers existed now, published and permanent, but they landed in a scientific world that did not know what to do with them. Physicists read the words, frowned, and moved on. The ideas were strange, unsettling, and worst of all, They came from someone without authority. Einstein was not part of the inner circle. He had no famous students, no powerful allies, so the universe-changing idea waited, unread. Years passed. Einstein remained in the patent office, his days measured by rubber stamps and quiet routines. Outside, the world moved forward as if nothing had happened. Inside his mind, the unanswered questions grew heavier. Had he gone too far? Had he misunderstood something fundamental? Or had the world simply chosen not to listen? At night, Einstein revisited his work with a mixture of pride and doubt. The theory still held, time still bent, motion still reshaped reality, but without gravity, it felt incomplete, like a story without an ending, and endings matter. The silence began to erode him. Einstein was not ignored loudly, he was ignored politely. Journals did not attack his ideas, they simply did not discuss them. Conferences did not invite him, universities did not call. It is easier to survive criticism than indifference. For a brief moment, Einstein considered stepping away from physics altogether. Remaining in the patent office was safe, predictable. The universe did not demand explanations there, but the unanswered problem followed him everywhere. Gravity. If space and time were flexible, then gravity could not be a force in the traditional sense. It had to be something deeper, something geometric, something that reshaped the very stage on which reality played out. This realization did not bring relief, it brought weight, because solving it would require unlearning everything physics believed about gravity. It would require abandoning certainty in favor of structure, curvature instead of force, geometry instead of intuition. Einstein worked in fragments, a thought here, a sketch there, nothing complete, nothing publishable. Progress came slowly, painfully, and still no one noticed. Then, quietly, something shifted. A few physicists began to pause over Einstein's papers. A few questions emerged, not agreement, not praise, just curiosity. And curiosity is dangerous, because once an idea takes root, silence can no longer contain it. Einstein sensed the change before he could see it. The questions became sharper, the letters more frequent, the resistance less absolute. The universe was listening now. But listening does not mean understanding. And understanding gravity would demand everything Einstein had left. If an idea survives years of silence, what happens when it finally demands to be finished? Einstein no longer thought of gravity as a force. That idea had failed him too many times. For years, gravity had resisted every attempt to fit inside his earlier framework. It refused to behave like light. It refused to submit to simple rules. The more Einstein tried to tame it, the clearer one truth became. Gravity was not something that acted within space. Gravity was something that reshaped it. This realization did not arrive as a breakthrough. It arrived as a burden. Because if gravity was not a force pulling objects together, then space itself could no longer be flat. It had to curve. It had to bend. It had to respond to mass the way fabric responds to weight. The universe was not a stage. It was a participant. Einstein began to imagine space and time not as separate ideas, but as a single structure. Flexible, responsive, and fragile. Massive objects did not pull on one another through invisible strings. They changed the shape of the space around them, and motion simply followed the curves. It was a beautiful idea, and an impossible one. The mathematics required to describe curved space was not part of Einstein's training. He struggled to translate intuition into structure. Every attempt felt like reaching for something just beyond his grasp. This time, imagination was not enough. Einstein asked for help. For the first time, he admitted that the problem was bigger than him. He reached out to mathematicians who spoke a different language, one of geometry, tensors, and abstract forms, concepts that felt cold, impersonal, necessary. Progress returned, but slowly, painfully. Each step forward revealed new complexity. Each solution introduced new contradictions. Einstein questioned himself constantly. Had he overcomplicated the universe? Had he mistaken elegance for truth? The doubt returned, sharper than before. But then, piece by piece, the structure began to hold. Space curved, time slowed, mass dictated geometry. The equations stopped fighting him. Einstein realized what he had done only when he looked at the result as a whole. He had not fixed gravity. He had rewritten it. Gravity was no longer a force acting across space. It was the shape of space itself. The implications were terrifying. If space could curve, then light could bend. If light could bend, then stars could lie about where they were. The universe could distort its own image. And if that was true, then reality was far stranger than anyone imagined. Einstein prepared the final version of his theory with a sense of exhaustion rather than triumph. Years of silence, years of error, years of waiting had led here. But publication was not victory. Proof was still missing. The universe would now have to answer back. If space truly curved, the stars would reveal it. And if the stars did not, then everything would collapse. If gravity is not a force, but a shape, what happens when the universe puts that idea to the test? Einstein knew the theory was vulnerable, not because it was weak, but because it demanded something rare. Proof. Equations could convince mathematicians. Logic could persuade physicists. But the universe did not care about elegance. It only responded to truth. If space truly curved around mass, then light itself would not travel in straight lines. It would bend, quietly, precisely, and that bending could be measured. The problem was timing. The test required a total solar eclipse, a moment when the sun's overwhelming light disappeared, revealing stars hidden behind it. Only then could the positions of those stars be compared. Only then could space betray its shape. Einstein waited. Not days, not weeks, years. When the opportunity finally arrived in 1919, Einstein was not present at the edge of the world where telescopes were set. He did not peer into the sky. He did not adjust lenses or expose photographic plates. He waited. Again. While others traveled across oceans to observe the eclipse, Einstein remained behind, suspended between faith and fear. If the stars appeared where Newton predicted, his theory would collapse. Years of isolation, years of doubt, years of struggle, gone. But if the stars shifted, even slightly, then space itself would confess. When the results arrived, they did not come with drama. No thunder, no announcement. Just numbers, small deviations, tiny angles. Enough. The starlight had bent. The universe had curved. Newton had been wrong. Not because he failed, but because he had not gone far enough. Einstein's theory survived its first encounter with reality, and the world reacted instantly. Newspapers did what journals never had. They listened. Revolution in science. New theory of the universe. A German scientist overthrows Newton. Einstein became something he had never been prepared for. Famous. But fame did not bring peace, because Einstein understood something the headlines did not. The theory had not answered everything. It had opened doors. Space could bend. Time could stretch. Reality could distort. The universe was no longer a machine. It was dynamic, responsive, alive with structure. Einstein did not celebrate. He reflected. Because the greatest discovery of his life had come from a single act of defiance, trusting a thought when no one else would. Einstein never rode a beam of light, but by imagining it, he reshaped the sky itself. If the universe can bend to a single idea, what truths are still waiting for someone willing to ask the wrong question?